this video, we're going to talk about the first method of systems of equations. The first method we're going to talk about is the graphing method. Apologize for my dog barking in the background. Adds a little flavor to my video. So when we're graphing linear equations, we have three potential solutions, like I discussed in the part 1 of systems of equations. Notes. So we have three options. My lines can either intersect here. They can never intersect, meaning they're parallel, or they can intersect on top of each other, which means they intersect everywhere. So if my two lines intersect in one spot, they have one solution. If they intersect never, they have no solution. And if they're stacked on top of each other, how many solutions do they have? Well, they have infinite solutions. Okay? So one solution, no solution, infinite solution. Those are the number of solutions. When you have one solution, your answer is that ordered pair. It's that ordered pair where those lines meet. It's that point right there. If I have no solution, my answer is no solution. And if I have infinite solution, my answer is infinite solution. How I get no solution if my lines are parallel? And how I get infinite solution, my lines are stacked on top of each other. So that's with graphing, you have one of three potential answers. So if I go ahead and I erase and I scroll down, it says find the solution to the systems of equations. So I know I'm looking for where my lines intersect because I have two lines. So I'm going to highlight one line in one color and I'm going to graph it. In order to graph a line, what two pieces of information you need to know? Well, I need to know what m equals and I need to know what b equals. So in that top equation, what's m? M is always next to x, so m is 3 over 1. And what's b equal? B is always alone, so b is negative 2. When you're graphing, what do you graph first, m or b? When you graph b first, b goes on the y-intercept. And then I apply rise over run. Rise 3, run 1. Rise 3, run 1. It is very important that you go completely across your grid. So notice I still have some space down below, so I'm going to go down 3, left 1 to connect all of my dots to my graph. And I have to do this because I have to make sure I get the answer. And then I'm going to go ahead and I'm going to connect my dots. So now I want you to highlight the next equation in a different color. And I want to determine what m equals and what b equals. What is m equal? What number is hiding between the negative and x? Well, that's negative 1. And my constant is 6. So, b first, 1, 2, 3, 4, 5. So b goes off the graph, but that's okay. And then it's 1 over 1. Excuse me. So I'm going to go down 1, left 1 because, I'm going to go down 1, right 1 because it's negative. Down 1, right 1. Notice right here, a purple dot and a green dot just overlapped on top of each other. That means you probably did it right. Down 1, over 1, down 1, over 1, down 1, over 1. And I'm going to connect my dots. And with the systems of equation, my answer is the ordered pair where they intersect. So that's my answer I'm going to write. So that ordered pair is 2, 4. If we go ahead and we do number 2, I'm going to look at the first one. M equals, B equals. M equals 1/2, B equals negative 2. So plot B first, which is negative 2. Up 1 over 2, up 1 over 2, go in the reverse direction to go completely across your grid. Connect my dots. If I look at my next equation, can I instantly graph it? No. Why not? Well, y is not by itself. So to get y by itself, I have to subtract 2 2x on both sides. So y equals negative 2x plus 3. So y is now alone, so now I can figure out what m and b equals. M equals negative 2 over 1. B equals 3. So plot 3, down 2 over 1, down 2 over 1. Notice a pink dot just filled an orange dot, which means I probably did it right. If I ever were to graph these and the pink and the orange dots don't overlap, like if I were to put a point and it'd be like right there, that means I probably did something wrong because that point would be an ordered pair. I would be a decimal. So I'm now going to connect my dots. And I'm not done because my answer is always where? Where they intersect. They intersect right there. That value is 2, negative 1. So the really powerful thing is you can easily check these answers on Desmos. Graphing systems of equations actually ends up being everybody's least favorite, even though it's really easy, but it's usually everybody's least favorite because it's really easy to make mistakes. Accidentally making a positive slope when it's supposed to be negative, or plotting B in the wrong spot. It's really easy to make silly mistakes, so you have to be very careful. So a wonderful tool to check your answer is to use Desmos. So I'm going to go ahead and clear my screen so I can shrink it, so I can show Desmos up here on my screen. And my answer here was 2, 4. And my answer here, I believe, is 2, negative 1. We're going to find out really quickly if I did this wrong. But if you go over to Desmos and you type in y equals 3x minus 2, hit enter, typing in x1, y equals negative x plus 6. Notice they intersect. Click that point. Where they intersect, it's at 2, 4, which is what I did correctly. And if I do example 2, y equals 1/2, I have to hit the right arrow to get off the fraction, minus 2, and 2x plus y equals 3. If I click where they intersect, I get 2, negative 1. So sure enough, I did it correctly. So Desmos is wonderful because you can always check your answers to ensure that you get the correct answer. Okay? So if we go ahead on your notes packet and we flip the paper, let's do a couple more together. If I look at example 3, I'm going to take the first equation. Can I instantly graph it? No. Why not? Because y is not by itself. So I'm going to add 2 to both sides. So I have y equals x plus 2. So now I can say m equals b equals, because y is alone. What number is hiding in front of x? 1. So m is 1 over 1. And b is 2. So plot 2. Go up 1 over 1, up 1 over 1, up 1 over 1. I have to go all the way across my grid so I can make sure I find the intersection point. And it makes it easier to draw straight lines when you don't have a ruler. If I look at this next one, technically is y by itself? Yes, so I can be able to figure out what m and b equals. It's just backwards. M is always next to x, so negative 1 over 1. Do I have b in this problem? No, so b equals 0. So I'm going to plot 0, and then I go down 1, right 1, down 1, right 1, all the way across my grid, and then I go in the reverse direction. Notice a purple dot overlapped a green dot, which means I probably did it correct. So if I connect my dots, which I just did terribly, let's try one more time. Am I done? No, because I have to write my answer. My answer is negative 1, 1. My answer is where they intersect. And again, I could check this on Desmos if I would like. And the wonderful thing about Desmos is you do not have to put it in y equals mx plus b form. It graphs it for you in any form that you have. And if you were to check it, they would intersect at negative 1, 1. I want you to go ahead and I want you to pause this video and I want you to try example 4 on your own. When you finish example 4, unpause this video and we will go over it. Oh, and there's actually a typo now that I'm looking at it. Let's try changing this 5 to a 6. Change that 5 to a 6. And I want you to try it. And then if you get stuck, or if it works, because I don't know if it works, because I just told you to change 5 to 6, unpause this video and we're going to do it together. So I'm going to take this first equation and divide everybody by 2. So I have y equals negative 3x over 2 plus 3. So m equals negative 3 over 2, b equals 3. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Connect my dots. I have my first line. If I look at this next equation, I'm going to subtract 3x first because I'm trying to get y by itself. Divide by 2. Y equals 1 minus 3x over 2. So m equals negative 3 over 2. B equals 1. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. That's terrible. I want to erase. Maybe one day. So what do you notice about those two lines? Well, they never intersect. So because they never intersect, what's my solution? No solution. Okay. So I want you to go ahead and I want you to do numbers 5 and number 6. And when you finish number 5 and number 6, you can be finished. So number 5 and number 6, and then you are done.